Welcome back everyone. In this section, we are going to see how we are going to install and configure Hyperledger Fabric network. In the previous section, we have seen how are we going to install the peer chain code and how are we going to instantiate the chain code and how are we configuring the endorsement policies and how will we configure the endorsement policies for the private data which is present in Hyperledger Fabric network. In this section, we are going to look into these concepts, which are modifying the world state database configuration, defining initial multi-organization configuration policy, how are we going to configure ordering service, configuring Hyperledger Fabric container, defining the network configuration option, how are we going to enable the TLS for the communication, how we are going to generate the Genesis block and the commands that is used, and how to configure the service discovery node. Let's get on to the first topic, which is how we are going to modify the world state database configuration. Before moving on to that, to refresh your memory, a ledger consists of two states which are related to each other. One is blockchain and the second is the state database. State database is also called as world state data. So I have already explained that in previous sessions as well. So if you have not understand those concepts, please go back and revisit those lectures. And we know that the blockchains are immutable, and that is the reason once a block has been added to the chain, it cannot be changed. In contrast to that, world state is a database containing the current value of the set of key value pairs that have been added, modified, or deleted by the set of validated and committed transactions in the blockchain. So in order to modify the world state database configuration, you have two database option. First is level DB and the second one is CouchDB. In Hyperledger Fabric, level DB is the default database. So you can configure the state database whether you are going for level DB or CouchDB, and this configuration can be done in two ways. The first configuration way is using core.yaml. Now let us look into how we are going to set these details of world state database in core.yaml. So CouchDB is enabled as state database by changing the state database configuration option from Go level DB to CouchDB. This means that the state database configuration by default will be pointing to Go level DB. So that DB has to be changed to CouchDB for rich queries. So additionally, CouchDB address needs to be configured to point to CouchDB to be used by the peer. The username and the password properties should be populated with the admin username and password if CouchDB is configured with a username and password. So these changes has to be done in core.yaml and it will be effective immediately after restarting the peer. The summary of this is whenever you change the database from Go level to CouchDB, like any other database, if you have worked with MySQL database, you need to give a username and password. So same way, if you are using CouchDB also, you need to give the username and password, and these changes has to be present in core.yaml. And the other way of modifying the world state database without core.yaml is using the Docker environment variables. So Docker environment variables will override whatever the default values that you have given in core.yaml. So when you give the values like this, for example, core ledger state database and other states like other variables like this. So when you whatever the value that you are going to give for this particular variable will be overridden by it will override the values that are present in core.yaml. So CouchDB hosted in Docker container supplied with Hyperledger Fabric have the capability of setting the CouchDB username and password with the environment variables passed with the CouchDB user and CouchDB password environment variables using Docker Compose scripting. As we have seen in code.yaml, we are going to set a CouchDB username and password. In Docker environment variable, if you want to override those variables, then you are going to set those value using these variables. So these variables will override the values that are present in core.yaml. So if you have already updated the CouchDB, then how are you going to upgrade the CouchDB if you want a newer version or if you want a new instance? For that, what you have to do is, so you have to follow these four processes. So you have to first stop the CouchDB, then you have to take the backup of the CouchDB data directory, and you have to install the latest CouchDB binaries or update deployment script to use a new Docker image. Later that, you have to restart the CouchDB, and after this process, your peer will be using the latest CouchDB instance. Next is Next topic is defining initial multi-organization configuration policy. So we have already covered in the previous session how are we going to configure all these in config.tx.yaml. If you want to refresh the memory, please go back to the previous session and have a look and come back to this session and follow along. Next is configuring ordering service. So configuring ordering service is done in a file called orderer.yaml file. So setting up the ordering file, it takes a step-by-step process. So the process of bootstrapping an ordering node consists of the following four steps. First is creating the organization where to which your orderer node belongs to. Then you have to configure your node using obviously orderer.yaml file. Then you have to create Genesis block for the orderer system channel. Next, you have to bootstrap the orderer. So we will look into one by one of all these processes. So first step in setting up an ordering node is creating an organization definition. Like peers, all orderers must belong to an organization that must be created before the orderer itself is created. This organization has a definition encapsulated by MSP that is created by certification authority dedicated to creating the certificates and MSP for the organization. If you recall from the previous section, while the network formation, I have explained that the orderer node should be part of a particular organization, and that particular organization will be facilitated by a certification authority. That certification authority will be responsible for providing certificates for the orderer. So uh, that is where this CA and MSP comes into picture. If you want to refresh your memory, please go back and revisit those lectures and come back and continue. Next step is configuring the node. The configuration of the orderer is handled through a YAML file called orderer.yaml, which we have already seen. The Fabric CFG path, which is an environment variable, and it is used to point to an orderer.yaml file which you have configured, which will extract a series of files and certificates on your file system. So if you want to get more details of how this orderer.yaml file looks like before we get on to lab, you can check on this Fabric sample GitHub repo, which will take you to that particular GitHub repo where you can see the properties that are present in orderer.yaml. Next step is configuring the node. In orderer.yaml, you have certain properties which you will find in orderer.yaml file. We will visit certain important properties here. You have local MSP ID. This is the name of the MSP generated by your certification authority of your order or organization. So this is where your order or organization admins will be listed. And you have property local MSP dir, which is directory. So this is the place which is nothing but a file system place where your local MSP is located. Then you have other options as well. You have TLS. So if it is by default, it is disabled, which means the value will be false. So this is where you specify whether you want to enable TLS or not. So if you set this value to true, you will have to specify the location of relevant TLS certificate. So this is not, so note that in version 2.0, this is mandatory for raft nodes because the in version 2.0, we will be using raft as a consensus mechanism. Then you have the property bootstrap file. This is the name of the Genesis block you will generate for the ordering service. Then you have bootstrap method. This is the method by which the bootstrap block is given. Next, next in the process, you have to generate the Genesis block of the orderer. So the first block of a newly created channel is known as Genesis block. Since this is the first block, it's called Genesis block. If this Genesis block is being created as part of the creation of new network, in other words, if the orderer being created will not be joined to the existing cluster or orderers, then this Genesis block will be the first block of the orderer system channel. We have learned about different types of channel in the previous lecture. So the Genesis block of the orderer system channel is special, which means it must be created and included in the configuration of the node before the node can be started. Now, how are you going to bootstrap this orderer node which is prepped using the previous step? So once you have built the image and created the MSP, configured your orderer.yaml file, and you have already created the Genesis block, you are ready to start your orderer using the command that looks similar to this. And I'll explain and I'll type this command when we go for a lab section. So for time being, you have to remember that this is the command that you have to execute in order to bootstrap the ordering node. For bootstrapping, so we are going to use something called Docker Compose. So this is not a session for learning Docker. If you want to learn Docker more in detail, please subscribe to other courses which are present in coding bootcamps. For time being, you have to remember that you are going to use Docker and Docker Compose file in order to bootstrap the ordering node. Next is configuring Hyperledger Fabric container. So this can be done using another configuration file, another YAML file, which is dockercompose.yaml file. So before you can create a peer, you need to customize the configuration file for the peer. In Fabric, this file is core.yaml file. So there are quite a number of parameters you need to set for your network to work properly. So you will have below options which you can use for you to tune your configuration for your network. So you have to edit the YAML files bundled with the library, and you have to use the environment variables to override when deploying. As I told before, you either have to use the YAML property files, or you can use the Docker property file to override whatever the properties that are present in the YAML file. Meanwhile, you can also specify flags on the CLI command as well. So moving forward in defining the network config option. So option 1 has the advantage of persisting your changes whenever you bring down and bring back up the node. So the downside is that you will have to port the option you customized to the new YAML when upgrading to new binary version. So what does this mean? So you have this previous option, which is edit the YAML file bundled with the binaries. So if you go with this first option, this is the advantage, which means the advantage is you can persist your changes whenever you bring down or bring back the node. But if you use the other two options, which is environment variables and specifying the flag, that means it is not persistent. Every time a environment variable is used to override, so this environment variables will override the existing YAML file, and it is not persistent if your network goes down. And the same thing goes with CLI commands as well. So these are some of the properties that are present in core.yaml that are explained here. So peer.local MSP ID. This is the name of the local MSP of your peer organization. This MSP is where your peer organization admins will be listed, as well as the peer organization's root certification authority and TLS certification authorities certificates are present. You have peer.msp config path. This is the place where the local MSP of the peer is located. You have peer address where it represents the endpoint to other peers in the same organization. This is important to establish the gossip communication within the organization. So gossip communication is necessary to identify the other peers that are present in the organization. Then you have peer.tls. When you set this to enable or when you set this to true, then you have to specify the location of relevant TLS certificates. You have property like ledger. So in this, user have number of decisions to make about the ledger, including the state database, as we have discussed before, which has two options. One is level DB and couch DB. And this is where you can give this property and you can tell that this is the DB that we are going to use for state database or world state database. You have another property, gossip. So gossip data dissemination protocol is very much necessary for communicating between the peers and communicating to other peers as well. You have chaincode.external builders. This field is important to set when using chaincode as an external service. So there are many other properties as well. As you go through these properties, you will understand, as you go through these YAML files, you will understand there are many properties which are necessary for your network to have additional functionalities or customized functionalities in your network. One more property that you can set is enabling TLS for communication. So to enable TLS on peer node, you have to enable peer.tls.enable to true. So when you say TLS is enabled, you are telling that I want to securely communicate within the peers. So for that, you need to specify proper TLS server certificates as well. Next is how you are going to generate the Genesis block. As we have seen from the previous lectures that we need tools to generate Genesis block, and that tool is config txgen tool. So for config txgen tool, we are going to provide certain inputs or certain params like this. So you are going to provide profile, you are going to provide channel ID, and you are going to provide output block. So this config tool is the command that you are going to execute, and it will be fed to config txgen tool. This will generate the orderer Genesis block. Here is the property that you have to set for configuring service discovery node. So you are gonna specify the one peer which is going to act as a service discovery node. Here in this slide, we are setting that peer, that gossip peer for service discovery node as peer 1 of organization, which is running on port 8051. That is it for this lecture. Please go through this lecture and understand each concepts. This will ease you in uh, when we go for lab section. So if you have any doubts, please feel free to ask in the comment section, or please feel free to subscribe for the private tutoring session for one to one guidance. Thank you for watching. I'll see you in the next session.